Hello, everyone. Thanks for joining the session today. My name is Usman Zubair. I'm the VP of Engineering at Soapy.ai, a no-code test automation platform for mobile apps. The topic for today's discussion is improving developer productivity using no-code tools. For this discussion, we'll be focused on building and shipping mobile apps faster using no-code tools, but this learnings can be applied to any application today. For those of you who might have studied App Annie's State of Mobile 2022 report might already be aware that mobile app users spend nearly 3.8 trillion hours using mobile applications in 2021. In the same time frame, 230 billion new applications were downloaded. You can only imagine what that tells you for the data for 2022. Mobile app adoption has seen significant rise in the last couple of years. Users are spending more and more time using mobile apps in their daily lives. What this means is that mobile app users today expect a very high quality bar at all times. Failing to do so will result in mobile application users churning from the applications, or a lot of non-satisfied mobile application users. Quality for mobile applications can be multidimensional, but at the bare minimum, mobile app users expect that the functionality of the application, as expected, should work at all times across all devices and under all conditions. Which means mobile app developers or testers need to invest significant amount of time doing functional testing on a wide range of devices available today. At the same time, the user interfaces should be very easy to use so that the user experience is as frictionless as possible. And like I said, with a wide range of operating systems on Android, different operating system versions on iOS, different form factors, different device manufacturers, mobile app users expect that all these applications would work flawlessly on all these devices. Not only that, they also expect that the mobile application would gracefully handle and perform under all sort of conditions, whether it be like a very high speed Wi-Fi network, mobile networks like the 5Gs and the 4Gs, or a low speed network. They expect the app to gracefully handle all these conditions and give a good user experience. Also, with devices available with different form factors, it's imperative that these applications are responsive to all these different form factors and the user experience is not compromised from one device to another. All of this means that mobile app users want constant updates on their mobile applications at a much faster rate, and at the same time, they expect a very high quality bar of these releases. This means engineering teams today don't have the luxury of shipping once a year, once a quarter, or once a month anymore. The fast-moving mobile-first world demands that engineering teams must release apps faster. Think of that weekly or ideally shipping daily. But not only that, at the same time, ensure that these releases maintain a very high quality bar, meeting all the user quality expectations. To ship faster, test automation can play a significant role in helping developers ship releases faster and also ensuring quality. However, we all know there are several challenges today that stand in the way of ensuring faster and resilient test automation. In the next section, we'll look at some of these challenges today that the developers face while writing faster and resilient test automation. First up, when talking about functional test authoring, in today's conventional approach, it takes a lot of time to author tests. For both Android and iOS, there's specialized testing frameworks that require significant engineering skills to not only write scripts, but at the same time maintain those scripts. Additionally, if you think about mobile application releases, a huge amount of time is being spent on buying right set of devices, the right set of tools, and the environments and configurations for these devices, which can be a very cumbersome and time-consuming process. Additionally, authoring takes skills to actually access the underlying platform APIs for both Android and iOS. And if you're writing tests for special environments, that is time-consuming. All in all, functional test authoring in today's conventional approach requires a lot of engineering skills as well as a lot of time investment needs to be made in setting up the environments for your test. However, if you look on the right-hand side, no-code automation tools today give you the capability and shield your team from all these complexities. You don't need to worry about writing and maintaining scripts. You don't need to worry about setting up your environments. You don't need to worry about specialized APIs for both Android and iOS. And you don't need to worry about any custom or different tools to integrate in your test suite set when dealing with custom code APIs and mobile browser and similar tests. Additionally, when it comes to automating visual testing, in conventional approach today, we require different tools for different platforms that may not necessarily integrate with your tests accurately and requires maintenance of these different tools for different platforms. Not only you have to define these tests manually as well, but at the same time, at the end of the result, you have to go and compare visual images for discrepancies, which is a very time-consuming and manual process. Whereas a good no-code automation platform today will help you not only shield the complexity of choosing all these different visual quality tools, but at the same time do the heavy lifting of comparing visual images and finding visual discrepancies at a much faster scale as opposed to doing that manually. Talking about performance testing, much like visual testing and functional testing, both for Android and iOS, there are specialized tools that actually capture the performance matrices. So as a developer, you need to specialize in both these of tools and incorporate them in your test, which requires not only a learning curve, at the same time, engineering skills as well as maintaining these tests. You need to instrument your applications today and analyze the reports for anomalies, which can also be a very time-consuming and manual process. And then at the end of the test, you're manually comparing logs for discrepancies between iOS, Android, and other platform tests manually, which again poses a lot of time and effort in running and maintaining these tests. A good no-code automation platform will do all this heavy lifting for you and shield all the complexity from the developer when it comes to performance testing. And finally, when you're running these tests at scale, today's approach requires you that you have an in-house 24/7 environments or use third-party subscriptions to run your test. You require technical skills to actually troubleshoot any failures. And then you require hundreds of device metrics to make sure that you run your test and validate them on all locales. A good test automation framework would help you not only with the device coverage, but also remove the complexity of managing these environments 24/7 in-house and making sure you remove the test flakiness based on UI changes and different form factors. Similarly, reporting and analysis today in conventional testing is also a very manual process. Not only developers go and analyze logs for performance testing, they have to look at individually all the tests to make sure they find the root cause of why the test cases are failing. Is it either due to a product issue or a test issue? There are many iterations between the QAs and the devs to find the right repro steps. And identification of test flakiness and autocorrection and self-healing is also very difficult in today's conventional approach. Whereas a no-code automation platform gives you all these capabilities where it does the log analysis for you on different environments to find the failure patterns and not only help with flaky tests but also self-healing of your tests. It can also give concrete steps to your developers or testers so that they can get to the root cause of the bug or an issue much faster. So now let's quickly see a demo of Sophie.ai and see how Sophie's no-code automation capabilities can help you not only author test cases, but also run them at scale, along with collecting the performance matrices and also doing visual quality validations without writing a single line of code. So once you have signed up and logged into your portal.sophie.ai account, you will land on this dashboard. This dashboard gives you a quick overview of all the applications that are available in your account, along with the platform on which they were built. You can also click on this Add App button on the top right and add a new APK or an IPA file, depending on what applications you want to test. Once you've uploaded your applications, you can either do a quick test by acquiring one of these devices, see some of the recent test cases that were created, see the results that happened recently, and if there are any scheduled runs. You can additionally go to your app manager quickly and select a particular app. For example, in this case, I pick up the Hilton app and see more details on this particular app. For example, I can click on the Bills tab and it will tell me all the bills that were uploaded so far for this particular application, along with their version numbers and the dates on which they were uploaded. I can additionally go to the CI/CD tab, and since most of the application development today are tightly coupled with CI/CD platforms, Sophie has a lot of out-of-the-box integrations with popular CI/CD platforms to make it easier for developers to push builds to Sophie and test them as soon as they're available. So now, like I mentioned, Sophie is a test authoring as well as an execution platform. So let's quickly see how we can author a very simple test. So if you click on the device lab, this will show you a list of all the devices that are available for you under your plan. You can see what are the device manufacturers, the RAM, the operating system on the device, the CPU, and the model numbers. And You can additionally filter devices based on their names, the versions, um, and the device manufacturers to pick a choice of your device. Once you've done that, you can click on the Acquire button um, simply to acquire a device. For this demo, I've already acquired a device, which shows up here, and this is a Samsung Galaxy S Tab. So once you have acquired the device, this device will open up in what we call the Sophie Lab. So once you're in the Sophie Lab, um, this is basically mirroring the actual physical device right in a browser for you. So you can click and interact with the device just like you would do with an actual physical device. On the right-hand side, there are options for different actions that you can perform on this device. For example, you can change the orientation, you can click on the home button, you can clear text, you can toggle the Wi-Fi if you're doing Wi-Fi testing, and additionally set text fields or set the device location as well if you're doing GPS marking to test your applications in a different region. So now let's quickly see how can I record a very simple test and play it back. So if you go to the recording tab, click on the start recording, and there are two modes. You can either start fresh, which would clean the device cache, reinstall the app, delete any third-party apps that I might have installed as part of my ad hoc testing, and relaunch the app in a known state. Or I can continue from here, which would just continue the process from here. And it's very useful if I'm building templates to reuse across my test. So for this demo, let me click on Start Refresh so that now it's setting up the recording and going through the whole process that I just outlined of cleaning the device, reinstalling the application, and starting the device in a known state. Once it does that, it's going to relaunch the application so I can start recording. So now that you see that the Hilton app is back up, let me record a very simple sign-in test. So I can click on the sign-in button, and you can see actions are being recorded on the right-hand side. I can click on the username field and set the text. I can either type a text or select one of the test variables so that it's easier to use in my test. So in this case, I'm going to use the age honors variable and set the text. Then click on the password field. Do the similar process. I have the password in a different variable called hhn_password, and I'm going to do set text. And then hit sign in. So now it's going through the sign-in process. Hopefully after a successful sign-in, there you go, it's signed in successfully. Now let's say I want to perform a validation. The validation could be as simple as that. As soon as I log in, it should show me hi Sophie here. So now to add this validation, I can go into what we call the asserts mode. So if I click on the assert mode, it basically allows me to pick a component on which I want to add an assert. So in this case, I'm going to say I want to add an assert on this component. And now it's asking me what kind of assert do I want to add. So I can say I want to test the component's content in this case. And it should be equal. It should be equal to a text in this case. And it's giving me suggestions. Hey, hi, Sophie's in this. Do you want to match it to this? And I can say yes. And now it's asking me what type of assert is this? Do you want this to be a hard assert so that if it fails, the test fails? Or do you want to be a soft assert so that if it fails, it's just a warning and it continues? So in this case, let me just say it's warning and continue and add that assert. So now I've done that. This should be a very basic, simple test. And I can go ahead and save this test case and call it this one, demo DevOps Summit test one. Give it a priority. You can additionally give it a description or tag so that you can filter these test cases and then hit save. So now it's basically going and recording that test case and saving it so that you can rerun this on any number of devices. So you see, I didn't have to write a single line of code. So we did all the heavy lifting for me from setting up the device and to recording it. So now let's quickly see how can I run this tab. So if I go back to the automated tab and refresh, and this is the test case that I just did, I can click on it and hit play. So now Sophie is basically getting the device back into the same known state so that it can successfully play back the scenario that we just recorded. So now the playback has started. So we will go through all the steps that we just recorded. Hopefully The test successfully passes, performs all the steps. So now it's filling the username field based on the test data that we provided. Successfully does that. I'm going to fill the password field. Click on sign in button. Hopefully the sign in is successful, and then perform the assert validation in the end. Great. So the test actually passed successfully. You can see all the steps happened successfully. So now I can go into the results quickly to see the results. What I can do is, this was the test that just passed. I can click on it and it will take me to the test results screen. So let's quickly look at the test results screen. So what's happening here is basically showing me step by step all the details of all the actions that were performed by Sophie. So in this case, it was a very simple test successfully ran and passed. But imagine if you had a test case which was complicated and failed for some reason, you will want to compare it with the baseline. That's where the compare to recording feature becomes very, very important. So if you click on it, now it's giving you like step-by-step comparison between the recordings and the actual executions. So you can see step by step what you recorded versus what Sophie did when it was trying to play back. Additionally, if you click on the device metrics section here, so if you click on a particular step, it's showing you the memory consumption, the CPU utilization, the load time, and the network traffic for those screens. So you can see how much useful data Sophie captures out of the box for you without you having to write or integrate any tools. Similarly, if you go to the visual differences tab, you can click on run now. Now what Sophie is doing is basically doing an image to image comparison for all the screens between the recording and the playback so that it can perform a visual validation. So if I click on this screen, you can see most of these screens were similar because they were running on the same form factor and the same device, so you're not seeing a lot of differences. But if you click on the difference tab, you can see Sophie was able to diagnose that these are the differences in images between the recording and the playback. So now imagine if you're testing this on different device form factors and different devices, Sophie will be able to accurately pinpoint all the visual differences that happens across different device form factors and different devices so that your developers can quickly address those issues instead of like manually going screen by screen on all of these to actually figure out the visual differences. This is what I wanted to cover as part of the demo. Obviously, there's a lot more functionality in Sophie, but this covers the crux of the product where you can actually author test, play them back, and collect the performance matrices, see the visual differences, and run your tests without writing a single line of code at scale on hundreds of devices. I hope you enjoyed the demo. Please feel free to sign up on Sophie.ai, and I now will open this forum for any questions that you might have regarding platform or in general about this presentation. Thank you very much.